Hello, hello. Hey, thanks for coming today, guys. Appreciate everyone being here this early in the morning. If I could get everybody just to kind of move on up, please, so we can get just the group a little bit tighter, that'd be great, please. And sorry we're a couple minutes late getting rolling this morning, but again, thank you all for being here. My name's Jeff Kember. I am a cloud solutions architect with the GCP team. And in a former life, I was a CG Soup at Framestore, and I've had the pleasure of working at companies such as Blizzard and ILM and Pixar. We're going to have a couple different speakers come up and chat with you today. I wanted to introduce a new solutions architect that we have. So I have a media background from the film industry, and our latest hire, his second week with the company, Adrian Graham in the red shirt over there. Please give Adrian a bit of a welcome. For those of you who know Adrian, he is former Digital Domain in this very building. We worked together here, and he spent the last couple of years at Autodesk working on Bifrost and other cool next-generation Maya technologies. So this really is, I think, an additional statement on Google's emphasis to this market and vertical, that they're employing people like us to do this kind of work. So really excited to work with Adrian, and he's based here in the Venice office. So Google's cloud offering, we have a variety of custom solutions, and we also have Zinc. And I'm sure most people are familiar with it, but I'll go through it and talk just a little bit about it. It's a fantastic cloud rendering solution for those who have the opportunity to be able to work with a clean sheet version of Maya or Nuke. We have a cloud rendering solution for you. It allows you to render on demand, and it enables, there's a cloud file system, your files get uploaded, and the licensing is handled for you. So any of these products are available on a per-minute demand basis. The way the architecture works is you have an open source plugin that you download, and it works with Maya and Nuke currently, and you're able to take your scene, encapsulate it, and put it up onto the cloud. Your files are stored in the persistent file system, and the render nodes get spun up for you, and the pictures come back. The architecture is such that once the files are uploaded, only the change occurs. With Maya 2016, the bin files get uploaded from your local scene, and all of the render creation occurs on the cloud. So you don't have to do local writing of AS files and such for Arnold, for instance. And the same scenario works with Nuke. So renders that already exist in the cloud, when you want to run a Nuke comp, for all elements that have already been rendered in the cloud, they're already persistent there. Your final comp comes back to you. So it's a really great solution for smaller facilities that don't have custom plugins and their own pipeline. This gives artists the opportunity to scale significantly. This is what the interface looks like. I've already described how it works. This is the basically queuing control engine that lets you see what the progress of your job is and see how many render nodes you're running and how they're progressing in your job. So here are a number of films that were created using Zinc, and we're quite happy with the amount of success in the marketplace with it. So we encourage you to try it if you fit the use case for it. For medium and large studios, we have a framework for creating custom solutions. And these are the quick topics I'm going to run through today. It's a lot. I'll run through it as quickly as I can. From an ingest standpoint, we're peered significantly with most major markets on the planet. We're here in Wilshire and multiple locations here in Los Angeles. So your ability to get data into the cloud and get it back out again quickly, with Google's global network, we've leased ships and laid fiber under the oceans. So if you have other facilities in London or Singapore or Australia or Canada, we have the ability to be able to jump on and off our network, but it's private the entire time it's there. So normally connectivity is going to be over a VPN, and you're going to either do that over the public internet or with a CDI, a carrier direct interconnect, or letting up dark fiber. Either CDI or direct connect, you get a 66% reduction in egress fees. So that is significant. If you're in a position where you can light up dark fiber, we certainly encourage you to do so. We have a Google managed VPN solution where we manage the threads and throughput for you, so it's just plug and play and it works. Initially, we had a conflict where it didn't work with Avere, and now it does. That's been rolled out, so you can use our product, or you can roll your own. Any open source IPsec VPN will work. So the fabric that we run on is really kind of cool. Google buys roughly slightly more than 20% of Intel's global production. The next closest cloud provider buys 1% of Intel's global production. A significant portion of the Intel processors that we buy go into our software-defined networking. If you want to know a little more about it, there's a released last summer. There's a paper on Jupyter Fabric, and it's circa 2012. So it's a snapshot of what the technology was at that time. We're obviously a generation or two newer than that now. But it's a really cool paper, and it offers photographs of machine racks in the data center that you don't normally get to see. And it also offers architectural diagrams, and Urs is one of the authors. It's a cool piece. There's a blog and as well as a white paper. So if anyone wants to nerd out, I think it's a really great paper, and it's worth reading so you have an understanding of how are we able to get the throughput that we do. The VMs that we have are running now 16 gig sustained. So it's not like a 10 gig E connection with TCP over IP where you're losing 20 to 30% overhead. When we say it's a 16 gig sustained, we really mean that. The machines have in excess of 40 gig throughput per box. So in terms of cloud file systems, some customers are able to mount NFS directly. We've announced that we have compute opening up in Oregon, and the cool part with that is you'll be just over 20 milliseconds away from here in LA. So West Coast presence, really excited about that. That's a kind of late June, early availability July. The facility's been up and running for years, so it's not a new build. It's just we're carving off a chunk of it and making that available. Most of our customers end up putting a cloud file system. Even customers in London, where you can throw a rock to Belgium and it's a 7 millisecond ping, you're in a scenario where bandwidth becomes expensive and you're reading all the data at least twice for motion blur, as you know. So in that case, multiple reads, cache hits in the cloud are friendly. There are a variety of solutions. We support managed solutions such as Gluster from Red Hat. We also support read-through cache file systems, Avere, PixCache as well. The advantage of a read-through cache file system is the fact that you can deploy it and you have zero changes to your pipeline initially to get up and running. You can make a picture without modifying anything. The file system will immediately look to see if it's in the cache. If it's not there, it'll go to the core filer on-prem and get it for you. We'll talk a little more about that architecture. So this is just a straight-up cloud file system. In this context, you could deploy our no-cost single-node filer, and that is a framework that we have different file systems that run underneath it. But for you, it's a click-to-deploy option. So you get the same 16 gig throughput. You get a couple hundred gigs of RAM. You get terabytes of local SSD backing you, and then you can put between 10 and 64 terabytes of persistent SSD. I'll talk more about the storage, but it's a pretty beefy little server. It's not intended to be high availability. It's a single node, and it's not fault tolerant in that regard, but it works really well for kind of 50 to 100 nodes. If you want to scale beyond that, Avere is here today to talk with you about their offering. The virtual VFXT is a fantastic solution. What's cool about it is, in this example, you have the Avere on-prem, but you also have a virtual version of it in the cloud. Now, most of you who have an Avere product are used to it being a multi-terabyte box that's mounted in your data center. It fronts your core filer for you on-prem. The difference with the cloud version is that each node has multiple terabytes on it, and you can have 3 to start with and go to 10, 20, 30. We've had customers running 60,000 plus cores against 18 to 20 Avere nodes, and the Avere's not breaking a sweat. So you can scale up beyond 50 if you choose. So that really changes how you think about it. The on-prem appliance is, again, a smaller front-end cache where this is an entire file system. It's your core filer in the cloud. This is a slightly more advanced diagram here, which really the point of this is to try and show you have on-premises storage as well as cloud, and just to show the cross-connects that you have. This enables you to run hybrid rendering. So in this scenario, you can have artists submit to their local workstation, to the rack over in the corner, your colo up the street, and to the cloud. You can use a queuing system that will cut your image up into a whole bunch of different tiles, and you can distribute it over all of those different machines. And that's really exciting. The local machines will, of course, read off the local Avere, and the cloud machines will read off the VFXT. And Avere is going to jump on after I'm up and chat a little more about their product and also give you a demo of the interface. So from a storage option standpoint, the primary, when you think of Google Cloud Storage, it's a big block store, and that's not very friendly for visual effects work, but it's huge. Exabytes of data are available on it currently. The nice part about it, though, is that you can store files there really inexpensively. It's 2.6 cents a gig for the standard Google Cloud Storage, the GCS offering. Most visual effects customers who are parking data there, though, will use the durable reduced availability. It's kind of a strange name product, but what it is, it's 2 cents a gig, and it enables you to read the data as frequently as you want. So for production data you want to store in the cloud, DRA is a really great solution. You're not performing BigQuery and large data analytic workloads on it, so you don't need the super low latency of GCS, the slightly less availability, but still durable of DRA is great. Nearline's a cool product. I'll talk about it a little bit later. It's 1 cent a gig. It's our competitor to basically LTO tape solutions. It's 2 to 7 seconds to retrieve it. Persistent disk, that is our word for network attached storage. So the standard is spinning disks. Most everyone in this industry is using our distributed SSD variant of that. And you can do cool things with it, like take 50 nodes and mount the PD SSD read-only against them, and there's your inexpensive file system. So it's cool technology. The last item is local SSD, and that's the one I really enjoy working with the most, just in the fact that it's super high performance. For nerds in the room right here, it's 700,000 IOPS, which is really fast. It's basically the speed of DDR2 speed RAM, and we currently have it deployed 4 disks, striped, all that's taken care of for you. It's 3 terabytes in size. You can go 750 chunks up to 3. And of course, expect that to go up in terms of performance and size over time. But the cool part about that is if you're doing caching operations or simulation work, it's really great for I/O. So from a transfer standpoint, we have these are just suggestions for various tools. You use the GSUtil to be able to communicate with the cloud cluster that you've put up. And then everything from rsync all the way down to FTT to commercial offerings like Aspera and Signant are supported. So asset management, one of the exciting things, and I don't have a clock, so I'm just going to check. There we go. One of the exciting things about how to optimize the solution is looking at your asset management pipeline. So who here uses Shotgun in the room? Show of hands. Cool. Who has their own proprietary asset management system that they rolled themselves? Okay, great, show of hands, cool. So everybody here knows that if you throw up a read-through cache file system such as the Avere and you spin up a whole bunch of render nodes, you're still gonna have to transfer everything up. We've had really good success with customers who are doing something as simple as adding a single rsync. So let's say you're using Alembic, you cache out the animator scene, you do a quick render of it to make sure that the bake was good, and you wanna scrub through and RV and see that there's, here's the heavy rig that you did a play blast on, here's the cached version of that, scrub back and forth, animator goes, yes, it's good to go, punch the button and publish it. At that point, we have people insert a single rsync line. That cache file gets pushed up to the cloud. If you over-provision your file system just a tiny bit on the cloud, you're in a scenario where there's going to be very little flushing and it's going to be persistent. So by the time it gets down to lighting, all you're sending up is shader values and light positions because you already have your textures up, the characters are already up, the cache files are up, everything's been pushed up in advance. You don't care about performance with rsync because it's human time between when the animator clicks the button and when production assigns it to someone in lighting to pick it up. The files are already there. We also encourage people, just from an optimization standpoint, to cache, bake their files in the cloud. And again, uploading in advance is really optimal. Because our ingress is free, I would agree that it really, there is a cost to ingress and egress, but the way it's been priced is ingress is free and egress isn't for us. So in that context, you can push as much as you want to the cloud without having to pay additional money beyond using your own bandwidth to do it. We have some customers who do what I thought was clever, was they have a daughter process that after their EXRs are finished, they'll go through and create an H.264 of that, and they'll crush it down from a bitrate standpoint and resolution, and they'll pull just the H.264 down and have a look at it and make sure that the characters are in the right place, the lighting is correct, the paint stuck and all of that. And they're like, yes, the render is good. So then they'll actually download the EXRs at that point, which are 4K and 50 AOVs and the usual thing, half float. So in that context, you're in a scenario where you're not paying to egress something that you're not sure is a good render, so to speak. So from a queuing standpoint, we have a variety of queuing partners. We have representatives from Pipeline Effects here today, as well as ThinkBox. We support Tractor and Rush. We have quite a few customers who run their own queuing system. So it's a really hard problem, as everyone here in the room knows. And we've been working with all the providers of the top queuing systems to ensure that their queuing system works well on our cloud. It can communicate on-prem with an existing control head back and forth. So there's varying levels of cloud integration with these products, but we're happy to talk with you after about more information. And again, we have reps from those two companies here today to talk with you. So from a licensing standpoint, when I joined the company about 18 months ago, the group of us sat down and made a list of all the things we needed from a VFX standpoint in order to be able to deploy in the cloud. And like top of the list, well, right after cloud file system, was cloud licensing. And with per minute billing, you want to make sure you can also render in the same capacity. It's, difficult for me to get up here and say, hey, you have 1,200 frame shot, let's spin up 1,200 machines. It's 17 to 24 minutes or 2 hours a frame or 2.1 hours, and you only want to pay for the 2.1, not round up to 3. The immediate response I get back on that is, what about licensing? So today, Chris Nichols is here from Chaos Group, and he can talk with you a little after about their cloud licensing solution. So you can do per-minute licensing on our cloud that's fully dynamic. Deadline from ThinkBox has Krakatoa support, as well as Nuke from the Foundry, pretty much the whole Foundry product line, including V-Ray as well from Chaos Group. And Cube from Pipeline Effects has currently beta support for cloud licensing for their queuing system. So if you're a Cube user, you'll be able to scale dynamically on the cloud as well. If you're Cube and V-Ray, for instance, you could point at Chaos Group's server as well as the Pipeline Effects server. So these are really great solutions to enable you to be able to say, hey, I'm a smaller studio, but I want to compete with the large studios. Because as you know, 10 machines for 10 hours costs the same as 100 machines for 1 hour, but there's that nice 9-hour wall clock difference that you're saving. In terms of virtual machines, it's all the same hardware. The racks that I showed you earlier on the Jupyter Fabric page, that's the same infrastructure that all of Google's services run on. So Maps, Search, all the machine learning technology, everything runs across the same infrastructure. We pretty much have compute and storage. So this is not like a special roll your own version for GCP. This is the industrial strength stuff that Google runs everything on. And because of that, we have live migration support, and we're the only company that has this. It's the ability to basically snapshot a machine and move it to another box on another rack without interrupting the job. The live migration even supports use cases such as a file system that's under heavy load with local SSD. We can migrate that file system while it's running, and it'll take several minutes to do it, but we can actually move it without interrupting the job. That gives you huge amounts of uptime. That means that we can fail a power supply, we can have hard drives go down, we can have all sorts of the usual problems that one has in a very large-scale data center without interrupting the workflow. So that's a huge advantage with standard VMs. The other nice thing is, from a pricing standpoint, there's a sustained use discount. So if you want to use the machine 5 days a week, but you want to turn it off on Friday night through Sunday afternoon, however you want to use it, you only pay the lowest price at the end of the month. So the maximum discount is 30% off our standard pricing. However, if you use it 21 days of the 30 or 31, you're getting kind of a 22 to 25%. So you don't have to buy in advance or budget in that regard. You just pay the lowest price at the end of the month. Most of our customers for rendering are taking advantage of preemptible VMs. These are the same VMs that you're running standard jobs on, except this is excess capacity for Google. Unlike a rendering data center where you guys are running it at like 98% efficiency, well, 98% compute usage, I should say, at all times, Google runs with higher margins than that, and that enables search to be highly responsive and take significant loads. The scenario for preemptible VMs, 24-hour lease, they're 70% off, so you're paying 30 cents on the dollar. To give you an example, that's 32 cores with 120 gigs of RAM, stood up, including network and power and spares, is 48 cents an hour. So that's really inexpensive. When you do the math on what the total cost of ownership is, we're pretty confident that's a really competitive price. The machines do get taken back on occasion if we need capacity, or if we need to have that rack for some reason, you'll get a 30-second termination on it. Integration with your queuing software, we'll talk a little more about how to handle that. So VM strategies. So standard VMs, you want to use that for your gateways, your cloud file systems. If you have a render that's more than 24 hours, please put it on a standard VM. Do consider use checkpointing with V-Ray or PRMan or Arnold. Critical deliveries, if you absolutely have to have it tomorrow at a specific time and you don't want to have the job get interrupted potentially and then respin up a new machine and start from your last checkpoint, there may be a couple, maybe tens of minutes or more between the last checkpoint and where the machine stopped. Preemptible VMs, however, are fantastic for doing renders, normal work. nuke comps, any of that work is fantastic. I would also encourage simulation work to run on standards if it's something that's important to you in long running. Making your queuing software aware of preemptible VMs. We have a PubSub service that basically looks at the cloud log, and you can basically point your queuing system at that to look at whether or not a machine is going to go down. If that occurs, we encourage the scripting to be such that you send a termination to the machine of the job you're running. So if you can get an extra checkpoint out of it, great. You have 30 seconds to write the data and you're pushing it back to a cloud file system. It's usually successful. You also immediately stop sending jobs to that machine if you're bin packing. So if you have a 32-core machine and you're treating it like an on-prem rental, you may want to be running like 16 cores for render and some for comp and some for other jobs. If that's the case, you want to stop submitting jobs to that machine, you can immediately spin up another machine. It's just that we want that one back, but we still have stock elsewhere. So you can get another machine coming up, which takes about 45 seconds to get the machine up, and then you can start putting your render executable on it and loading data into it. So again, as one machine goes down, the next machine comes up, and you can get pixels back in roughly under 2 minutes, depending how large your scene is to load. So in terms of different workloads that we have, we're having great success with people running rendering workloads, but we have other customers who've come to us and said, hey, we've got a big effects show, and it's 10x what we have. And I'm sure everyone in this room has had issues with high I/O on the local network, where even if you have a physical caching solution on-prem, you're still in a scenario where, an example I can give, you have hundreds of fluid sims running at the same time. I had that on All You Need Is Kill was the name of the film, and Edge of Tomorrow was the final release name. That final shot in the Thames, we had hundreds of Naiad fluid sims going simultaneously, and it was just crushing the I/O on the file system. The caching appliance was being forced to flush because we were reading huge data sets and writing 20 to 30 or more gigs per frame out, and as a result, we needed to segment the network and use a different file system. So the opportunity to do that on the cloud is significant in the fact that our network is phenomenal and the file system performance is extremely high. Compositing, deep compositing. I know the standard workloads are, it takes too long to push up normal confs and then do the minor compute that's required and then pull the data down. However, for deep compositing, because the I/O is so significant, we encourage people to use the cloud for that, and the fact that that's really providing a significant benefit by not crushing their local renders. And for archive use cases, the ability to store the data on the cloud and have your entire tool chain from the previous file. I'm sure everyone here is running multiple shows in their facility, has disparate versions of environments and such. And if you want to go back and say, I want to restore that robot from the previous movie, but I also need to restore the entire environment that it was in, you can have a snapshot of that tool chain, you can have the asset available to you, you can get it in 2 to 7 seconds, as opposed to a multi-hour restore if you have it on-prem for LTO, as well as a multi-day restore if that file is elsewhere. So the advantage of this is it gives you the ability to let the artist work immediately. You can pull just the files off you want. You don't have to restore entire directories. And you're in a scenario where instead of saying, I need to pull back 20 gigs of something and realize it was actually stored in someone's home directory, you can actually traverse the file tree and get just the files you want. And it's only a penny per gig. You can also upload a 400 terabyte show because you have to get it off your local file system on-prem. But then if you have a little bit of downtime, you can put a talented pipe TA onto the job and go through and pare that show down and get it down to 225, 175 gigs, whatever you can get that show down to once you've already shipped it and it's already been shown in the theaters. You can get that minimum archive. That's hard to do with LTO. I don't know anyone who's actually online to LTO tapes and then pared them down before putting them back out. So the rental model is what people started with. The idea was Bob and Sarah come by with a truck and rack up 3 more racks, and you plug them in, you have enough network capacity, you have cooling and storage and physical foot space for the boxes to sit there. That's fine. Your queuing system picks them up and away you go. The problem with that model is that it doesn't scale as well as you might like it to, and in some markets it's difficult from a power standpoint. It's expensive to get power here in California. People often move to a colo model so they can have a larger physical space and make better use of their on-prem facility to put more artists and such. Companies in London where it's super expensive, they're out of cooling and power is a problem. The problem with this is it's fixed scale. The dynamic model is the one I'm most excited about in the fact that this is the wall clock savings. So if you run a significant number of machines for a short period of time, because we have permanent billing after the first 10 minutes, the cost is going to be the same to you if you run 1,000 machines in a 24-hour period as if you run 4,000 machines in a 6-hour period. But the difference is that the comper is able to work on that file tonight, and the lighting artist doesn't have to come in tomorrow and say, yeah, it's on tens, but it's still on the farm. You never have it still on the farm. You're able to get the shots through. And when you save a couple of days of production time, that's VFX time, that's producer time, all the different soups, leads, that's a significant per day cost that you're saving. Here are some of the customers that we're working with. Some of them are local, some of them are global in presence. Framestore had a really great success with us. They were one of our earlier customers. They put up a really great system, I think. They were running between 6,000 and 12,000 cores, and they were one of our early Avere launch customers as well. Tristan from Framestore participated in a webinar last fall, and he talked about being at roughly 2.6 gigs sustained throughput on a 3 gig link from SohoNet that could scale to 10. Once they put the Avere cache in place, they were down about 1.1 to 1.2 gig. So that would enable them to either double the number of cores on a fixed pipe size or be able to work with a significant reduction in throughput as well and still maintain the same number of cores. So one of the things I just want to talk briefly about is the total cost of ownership. And for us, I have performance on one side and cost over time, and in this example, it's just a 36-month amortization. So the on-premises, let's say for fun, you go out and you buy 5,000 cores on-prem, the performance is going to be the same. They will render the same amount over that period of time. So by the 36th month, if you're paying for it per month, the cost for the cores are the same, your per monthly cost if you financed it, and the performance is the same. With Google, our prices go down. We have a Moore's law of pricing. So we're doing reductions on a more frequent basis than 18 months, but we're pretty much doing the half every 18 months. So the price will be significantly less 3 years in the future than it is today. But the cool thing is that you get the architectural increases over time. So you'd go from Sandy Bridge, Ivy Bridge, you'd into Haswell, all the way to Skylake, Ice Lake. You can look at the future architectures. So on this graph, you can see that your performance is going to go up several architectures worth, and your cost is going to be down. And the nice thing is you're only paying for this for the minutes you're using it. If you have a slowdown in production, if you go back into story, if they want to shoot pickups, whatever that is, you can shut it off. If you've prepaid for compute, then you're in a story where you're just paying for it whether you're using it or not, and that's a completely different model. So we're getting really good adoption with this. So production safety valve, this is the idea that we work with customers and we get a proof of concept in before the project gets crazy. I have had calls on Friday afternoon saying, we're delivering Monday, we're crushed, can you help us? And then you scramble over the weekend to try and set something up. We can often do that. It depends on the complexities. It's so much nicer when you're involved in advance. The account managers have some credits available so that people can start. And most importantly, it's all about being able to make a single picture. As long as you can get a gateway set up, get your VPN set up, and you can either do an NFS mount, depending on where you're located. For here, we encourage a cloud file system. You can go with just a simple single load filer or a persistent disk to do a quick test. You upload a self-contained scene. You can render a frame. We do encourage everybody to identify the machines they have on-prem. So I'm sure everybody in the room has like 4 or 5 generations in their data center of different machines that they have on-prem, plus a couple different generations of workstations, depending on what artists are using them. I encourage people to go and take a scene that's self-contained so we can get network and network performance for storage out of the game. Put the local file on the machine, do a render of it. If it takes 20 minutes or an hour, that's fine. Put a weight on that and put that in a spreadsheet and say, the middle machine was a 1.0. Run it on your faster machines and your slower machines and come back with a number. Then benchmark all the cloud providers. Benchmark Google and go through and try our different architectures. We currently have 3 available, Sandy Bridge, Ivy Bridge. We have Haswell. You can imagine Broadwell maybe coming soon. In that context, the ability to say, this job will take 55 minutes on our bare metal. and it'll take this long in the cloud. That really helps from a scheduling standpoint and from a cost standpoint. Otherwise, it's like, well, hold on, that machine, the 32-row box, 48 cents an hour, but how does that equate? That also enables you to put a cost on your local render and say, this machine under the artist workstation, that has a Quattro 6000 in it. That's not it's a great card, but it's not inexpensive. And there's tons of cores. That box takes up physical space and requires spares and has cooling, and you guys know the drill. The opportunity to be able to say, to production, your render cost tonight is going to be this much. Even though you're using our on-prem, it's not free. I know it's rolled into the facility cost, but you can start attributing it to shows so that they say, fine, we're going to give up some of this for local, or we're going to borrow this, we're going to take some cloud compute and get the shot done more quickly. The ability to be able to, again, expand to other types of workloads, such as simulation and comp, really exciting because of the file I/O savings that you get on that. So please start early. We're happy to help you get set up. For those who do transcoding, we have the fantastic partners we have here. We also have FFmpeg, which is open source. YouTube is based on that. We have a cool pipeline that you can use with Cube or Deadline, or you can roll your own, or we use Tractor that enables you to spin up a VM, copy the file locally, and then be able to perform the transcode using our local SSD, and then make 28 different flavors of it in different codecs and different bit rates and such. But today, we actually have an announcement for you. Still in beta, not a public announcement, but for this room, we have ColorFront's transcoder running on our platform. So it's still in beta, it works very well. So we have a couple of initial customers we're working with who are running production workloads on it. But it's a really cool professional transcoder that'll do ProRes and everything else you want running on our platform. So thank you very much for being here. I'll be available to chat afterwards and answer any questions you may have, or point you to someone who knows the answer if I don't. With that said, we have Aaron from Avere who'll be joining us virtually. And is Aaron on board? Yes? I'm getting a thumbs up. Here comes the big screen.
Can you hear me, Jeff?
Yes, we can. Aaron, thanks for joining us today.
Okay, great. So that's a perfect intro. I appreciate the intro there. So what we wanted to do today was kind of give you sort of a brief introduction to how we would deploy the virtual FXT within Google Compute Engine, and what that sort of deployment from an installation configuration sort of looks like. So just to give a little bit of background on myself, I've been with the company for almost 7 years now, and I'm focused on the virtual platforms. So if you start deploying, or you start talking to us about deploying a virtual FXT, you'll probably see me at some point. Probably the same talking head setup in a leather chair, but maybe hopefully face-to-face at some point as well. So I don't know if you guys have the slides up there. Hopefully, yes. You can see the slides. You can see myself. Okay, there we go. So we just wanted to go through some of the steps that we'll typically do within a deployment, and then I'll do a demo of what we call our cluster manager, and we'll take a look at what the infrastructure looks like running within GCE itself. So as Jeff mentioned, we start out typically with a 3-node cluster, and each of these nodes, an Avere node, is going to be sitting on an instance type within GCE. And today we support the HIMEM 8 and HIMEM 32 instance types, and then we have a couple or a few different storage options. So on the persistent side, we'll support either 1 or 4 terabytes of persistent SSD, or on the local SSD side, we'll support 1.5 terabytes, and that's per instance. And again, we start out with a FXT cluster that's 3 nodes in size, and then as you need additional throughput, you just add 1 node at a time until you get to the desired throughput and IO levels. So for a deployment within GCP, obviously we'll need a project to install in. We'll typically talk to you, make sure that you have, from a quota point of view, if you just opened up your project, you may need to add some additional quota for either persistent SSD or instance type, depending on how many nodes you're spinning up. Then we do have a couple of infrastructure instances that we bring up. So the first one is going to be a NAT instance, and we use that to route API calls and any S3 calls out to GCS storage. So the reason why we have to have that is that API is accessible basically from the internet side. So within your project and within your subnet, we just need to be able to issue those API calls. And we use those for things like when we do HA failovers, if we're moving an IP from one instance to another, for example, we want to be able to move that IP transparently so that the workload continues even in the face of an instance failure. And we can do all that if we have access to the API. Obviously, to create instances within the cluster, we would need to do that as well. So the next thing that we do is we modify the firewall rules. We're actually using an IP address space that's typically above what gets assigned by Google. And the reason why we do that is we're using more IPs than the Google API will typically provide for an instance. And I'll show you a chart of what that looks like, a little graphic of that. Then the next step is we bring up what's called the cluster manager, which is another instance. And that gives you the graphical user interface for actually deploying the system. And I'll show you that within the demo. The next step is we go through, we use that UI to create the cluster. Then we basically UI into the virtual FXT once it's configured. We complete the configuration. And from that point, you're ready to mount your clients and start your workload against it. So if we'll go to the next slide, I'll show you what that looks like from sort of a graphical point of view. So within GCP, you have your project. You'll see we have a firewall rule that's allowing both, in this case, there was a 10.240 IP address space /16. And then we're going to use the subnet above that, which is 10.241, to add IPs into it. And you can see here we have 3 of our virtual FXTs. We have what I call here the shepherd, which is the cluster manager, and then the NAT box, which is sitting there routing any traffic that needs to go out to the API space. So the next thing that I'd like to do then is show you that cluster manager and actually go through the process of deploying a system. So let me quickly share out via screen share. All right, so hopefully you all can see that now. Can someone give me a thumbs up if they can? Verbal thumbs up. Sure. I can't hear anything, so hopefully it's either really quiet or like the audio dropped.
We can hear you.
All right, perfect. Thank you so much.
No problem.
So here we have a project, and I'm just showing you here the infrastructure piece. So I've got what we call the shepherd, which is our cluster manager, and the NAT gateway, and we'll see those running. I also have a client that I have connected to our FXT cluster that's already running. So what I'm going to do here is I'm going to connect into the cluster manager and show you the user interface for that. So here you can see I've got the user interface. I've got one cluster that's up and running. This is going to be like a cooking show where I create the VFXT, and then I'm going to jump to that one because I don't want to sit here telling jokes for 12 minutes while the cluster actually creates. But I do want to go through the UI for the creation. So when we create a virtual FXT, we basically logged into our cluster manager. And now I'm going to create a new cluster. So I'll just give it a name, 4, and a password for the user interface. Now I can choose the region that I want to deploy in, and also the instance type. So again, I have a choice of HIMEM 8 or 32, and then I can pick the number of nodes that I start out with. So I'm just going to start out with 3. In this case, I'm going to add local SSD as the option. So this is basically all the information that I need now to create that cluster. And what the system's going to do, once I hit the create VFXT cluster, is it will go out, it creates a job, and now the shepherd, you can see here, we've got startup under creation, and it goes through the steps of actually deploying those instances. So you can see that we're connected to the Google API. It's setting up the three different networks that we're using within that subnet. It'll go out, retrieve the image that we've shared out with your project, create a root disk, actually create a template for the instances, then instantiate each of the three instances, the virtual FXT instances, and join them into the cluster. So that when this is complete, you have a fully functioning FXT cluster. And so this typically takes about 10 to 12 minutes. So like I said, I'm not going to wait for that, but I'm just going to jump to the cluster that's already created. And you can see here all of the steps that the system went through. So it actually goes through, gives you the IP addresses that it's using, assigns those, pulls in the image, creates the instance, creates a snapshot of the template that it's going to be using, and then creates the additional 2 other instances, and then joins them into a cluster. At the same time, we're also connecting to a GCS bucket. So that's going to be provided automatically ready to go. It gets junctioned into a namespace, and then it's immediately accessible via NFS once the cluster is created. So as we go through here, it'll tell you what each node is using from an IP address space, updates the software if it needs to, and then gives you the IP address of the management UI so that you can log in. So that's the cluster as it's created. When you're complete, you'll actually have that system up and running, and then you can use that management IP to log into the system. And this is the virtual FXT. That's that one that we created that's running. As I mentioned, it has what we call a core filer, which is your backend storage, which is a GCS bucket, and it's junctioned into /GCS. So here I have a client that's already connected, that was connecting to it and running some load. You can see in the last half hour, we've actually got some load running through that system in a full namespace, accessible via NFS and SMB, tied to that GCS bucket and ready to accelerate the workload. From this point, and this is what the cluster actually gives you by default, then you could connect either additional GCS buckets, you could connect to a NAS device that may be sitting over the WAN that's directly on premise, and you can pull that in, accessible via your VPN. Whatever you need to actually create the system that's going to actually serve for your specific workload or your specific needs. So I'm going to stop here because my colleague Jim Thompson, and I see that handles media and entertainment for Avere. He's actually there today, and he's going to continue with the portion of the UI demonstration. So Jim, I'll go back to you.
Thanks, Aaron. So what I have here is, once we get up on the screen, oh, by the way, I'm Jim Thompson. I've been at Avere for, I think, maybe 2 more months than Aaron. I don't know if Aaron's still on live, but we had an argument a couple of years ago, who was, which employee number, and I think I beat him by maybe 2 employee numbers. I think I was number 21, he's number 23. Anyways, I've been at Avere a long time, and I cover the media and entertainment, the vertical domain. I cover all the West Coast as well as Australia and New Zealand. So what I'm going to do today is I'm going to walk through the Avere UI. What I have here is a couple virtual machines running on my laptop here within VMware Fusion. So I've created a 1 instance, a 1 cluster node, Avere caching layer. And I have, let's see if I can, I also have a Linux NAS box, as well as my MacBook Pro here is acting as a client. So what I'm going to do is I'm going to walk through some of the, we could spend a lot of time here, but I'm just going to walk through some of the highlights of the UI. So this is, like Aaron showed before, this is the dashboard, and you would probably, once you create an Avere cluster, you're going to spend most of your time here. Not too often you'll be messing around with settings, the other tabs. I'll go through them, but the dashboard is where you're going to gain most of your information. And if we spend a little bit of time here, you can take a look at, this is obviously what's happening today on your for your clients. I don't have a client. I could, I could show some traffic, but it's going to be just playing, AC/DC or something. I don't know if we want to listen to that right now, but nonetheless, I can take a look at the ops per second. I can also change this to the throughput, right? And I could also bring up latency. And again, this is client-facing. What I also can do is I can take a look at, drill down into either a cluster-wide view, or I can take a view of the vServer. Now, what a vServer is just a virtual representation of your whatever NAS product you have sitting behind us, or whatever object storage device you have, which could be, GCP as well as something on-prem. Could be, object storage on-prem, or could be a NAS on-prem. But I can actually, define what I want to look at here, depending on what I'm interested in at that particular point in time. I can change this time for the dashboard to be, by default, it's 5 minutes. I can, as you can see here, I can make it whatever I want. I could also select a date and time, which can be interesting. Say I want to look at something from maybe 2-3 weeks ago, 4 weeks ago. This goes back in time until you last rebooted the cluster or did an install. So there's a point where it actually removes some of the, or writes over some of the data. So let's go put this back at 5 minutes. There's different, the chart controls here, we can take a look at, we can change the colors on the ops per second. We have, client ops, which is obviously, we know what that is. That's the clients doing operations into the Avere cluster. This is the source, so I can change that depending on what I have. And then I can actually, change these colors if like, for myself, I'm slightly colorblind, so I might pick something where I can actually read it. But data management ops is the operations that we use for. We have a couple features called move and mirror, flash move and flash mirror. So those are the data management ops that you would see there if we were actually moving data from one particular core filer, which again is the storage repository, to another storage repository. Say you want to move from your local NAS box up through us into an object storage into GCP, or GCS, pardon me. On the bottom of the dashboard, we have a couple things that we need to make note of, which is the conditions. So these conditions could be either red or yellow. Red would be obviously an alert, and you'd want to definitely take a look at that immediately. If it's yellow, it's not too much of a concern. The conditions should usually clear by themselves. If they don't, then we want to take a closer look at it. The alerts is just what it is, alert. And what we have here is this, just before you guys came in, I added the core filer, which was my Linux NAS box. And of course, it gave me a couple of alerts here that I had actually removed it last night when I was testing. So the virtual server, again, the virtual server is a representation. It's Avere's representation of what these core filers are sitting behind us. We have one vServer, which is which is presenting all of the core filers sitting behind us into a global namespace. So that means that each individual export from the core filer is represented with a junction point. And I'll show you that when we get into the settings. The vServer has a group of client-facing IPs. We also have a cluster group of IPs as well. The client-facing IPs, we'd usually, it's up to the customer to roll into a round-robin DNS name to have the clients mount, and they would be pseudo balanced once at mount time. This is the core filer again. This is my Linux machine. I have this Linux machine set in read-only mode, or read caching, where writes are passed through. I have a verification with the core filer at 30 seconds. So what this is, the Avere caching layer is essentially a client to a NAS box, and then in turn, we're also a server. So this verification of 30 seconds is the same as what a client NFS attribute time would be, which would be 30 seconds by default. I can change that. The reason I have this is by default set up in case you have clients that could be accessing the storage device directly instead of going through us. So the Avere caching layer needs to go back and stat the file system for everything that we have in cache to make sure that we have the latest. Okay? Again, I only have one node. I could add a node, but this gives some information, some good information. It shows the IPs that are client-facing. okay, for my global namespace. It gives some performance specs such as the ops per second and the hit rate. Of course, the hit rate is, I don't know why it's 50%. I'm not sure about that. There is no activity going on, but nonetheless. And then the performance. We also have a tab here for clients, hot files, and cache. There's not, we're not going to see much here because I only have one client, and this client is actually my MacBook, which is through a NAT device, so it's not really picking up the true IP for it. But we would see a list of IPs that would be your clients if this was something live. And then the hot files is interesting. That will give you a whole list of the hot files at any particular point in time and give you the full path. So this is the full path to a file that I was actually accessing not too long ago, which is when I was playing AC/DC. Just to wake up this morning because there's no coffee left. So this is a new tab that we just put into the UI, and it tells the amount of space that we're using for reads, writes, total used space, free space, etc. And this is kind of interesting, especially when you have a couple different core filers sitting behind us. Every core filer that we proxy, we actually attribute a certain level of cache in there, DRAM as well as the next tier, which would be SSD or SAS drives, depending on the physical box. If it's a virtual instance, then it's mostly going to be SSD, either local SSD or the durable. So that's the most exciting tab. I'm going to go through some more boring things here in a couple seconds. But nonetheless, the analytic page is probably the next more exciting tab. What it does is it takes the dashboard information, and you can actually kind of extrapolate that and drill down a little bit deeper. So we can take a look at client-facing latency. We can actually determine, go back in time using this slider bar here, which is interesting. And then we have, these are canned graphs. Okay, you see ops per second, which we had before, but this is just a little bit easier to view. And what we can do with this, we can create any type of graph we want. So we can add a graph to this set, or we can actually create a new set. But you can actually so I'm going to call this client stats, and I'm going to choose the data that I want. So what I'm going to do is I'm going to scroll down and pick something that's interesting to us. Maybe we'll do ops in the client network. And then what I can do is I can break this out, right? Say I'm mostly interested in maybe access calls, lookup calls, and get adders and reader pluses. And then I can create this. I've used this actually a number of different times in actually troubleshooting some problems. So it can be really flexible and really important to actually create these and create different graph sets, and then just pop in there and take a look at it. Say you think there's some kind of high latency going on at your core filer for some particular reason, and we can kind of drill down into this. So this is the settings tab, and I'm not sure if Aaron might have touched on this a little bit. There's a lot here. There's probably no reason to go through everything here, but nonetheless, we'll go over some of the basic things that we've done. So there's sections here. There's a vServer section, which again, this is the Avere GNS that I created. This is a representation of all those other NAS devices sitting behind us, or object storage devices. And then we have the core filer section, which again, you're basically defining the core filer prior to creating a virtual server from that. And the cluster network is basic management stuff, general setup, and a few other things. And the last one is administration. You would go down here to actually take a look to update the software on it, or actually perform some maintenance on the cluster. One of the things under the cluster section that we usually spend a lot of time with, other than the tab which had FXT nodes and a dashboard, this is kind of you can drill down a little bit deeper here. Usually this will give you a little bit more information once we have activity, but you can actually do some activities here. I can change the name of this node if I want, or nodes within the cluster. And it'll also list, I'll go back, but since I clicked on this node, it gives me information about the node. One, I don't have IPMI connected. Of course, this is not hardware. This is the virtual machine. There's no IPMI. But nonetheless, here's the client-facing IPs and other performance information. And then at the bottom, it'll tell you the connections that I have back to my NAS box. Okay? And of course, some other information about the networking. If I were to, if there were nodes, say I had to expand my existing cluster, whether it's a virtual or bare metal, it would show the list of FXT nodes that were waiting to join in here. So this is how easy it is to actually spin up another Avere cluster. And actually, we'll see if we can, not sure how long this is going to take to boot up, but nonetheless, it'll be fun to see if we can do this. I'm just spinning up another virtual machine here. And while that's coming up, we'll move around to, we'll step through this a little bit more. So this is my V server that I have created. I've named it Avere-GNS. All right. There it is there. I can hit this to create a new one, or I can suspend this one for whatever reason, or I can remove this. Say I want to just get rid of the cluster, or for whatever reason I don't have that NAS, that core filer. I need to remove the virtual server first, and then I need to remove the core filer second. This is just details for that virtual server. The namespace is something else that's probably actually one of the more interesting pieces that you need to deal with. So I mentioned this before, in order to create a virtual server and have it represented, I have to have a junction point to represent those exports or that bucket or container from an object storage device. All right. So this is what I've done here. I've actually created a namespace with /vol. I could call it whatever. I can add a new junction here. Let's call it vol2. And I know that because I know that there's another export from my NAS box. I'm just defining the core filer here. And then if you have a number of exports, it's going to show up in this list here, right? So I already have a junction point for vol1. I'm going to create one for vol2. And then I'm going to submit that. Okay, so now I have two different directories on the top level, vol1 and vol2. And I could potentially just go ahead and mount that from a client without any problem. This is where I change my export policies if I need to do that. You probably would. This is where I create the rules. Once I create the policies, I would apply those. So for SMB, I would want to go into here. There's a few other modifications and settings we would need to do for creating a SIS or SMB share. And this is the managed core filer. So I mentioned before that we have vserver, which is the proxy definition for the core filer. This is where I would define a core filer. I have to define some type of storage device. We call it a core filer that sits behind us, some storage repository, before I actually roll something into my namespace and create a junction point. And that's about it. I mean, we could see if this guy has. It has. Okay, so what I did, I booted my second virtual machine up. So I would click this to add it to the cluster. Of course, it prompts me. One thing I need to make sure is I need to have enough IPs to accommodate this particular node. All right? And I know that I do. In other words, client-facing as well as cluster-facing. In a few minutes, this will come up and it'll show up in the first part of the screen. So you'll have node 1 and node 2. But that's how easy it is to add another node into the cluster. That's all I got. Next, we have Simon from Sada is going to come up and speak.
Way to close. That's all I got.
Wow.
Can you guys hear me? Yeah, there we go. So good morning, everybody. So my name is Simon Margolis. I'm the director of our cloud platform practice here at SADA Systems. I'm going to talk a little bit about what value we bring to this whole process and how we can help sort of orchestrate the entirety of using GCP and better adopting it for your workloads. So first of all, a little bit about who SADA Systems is. We've been doing this for about 16 years now. We started in 2000. I've been with the company for about 5 years now. I actually founded this business back about 4 years ago when GCP was in beta still. And we've been having a lot of fun breaking things since then. Obviously, things are a whole lot more stable now. We've moved, in total, 10 million users over to various Google products across the numerous pieces of our Google for Work business, and I'll talk a little bit more about that as we move on. We've been a Google partner since the year 2007, and we've been a Google for Work Premier partner since they announced that program, meaning that we're able to provide our customers a little bit more white glove treatment, a little bit more hand-holding, and really help you get the job done. In terms of the solutions that we offer, we work across the Google for Work spectrum. So we're not just a GCP shop, although that's all I focus on. We do apps, we do maps, we do search, of course GCP, as well as Chrome devices. And we offer a number of services. So we are, at the core of our business, a systems integrator and a consultant. We like to work with you, get to know your business, and help you navigate this network of products and options and offerings to make sure what we're offering you makes the best sense for what you're trying to accomplish from many angles of your business, not just IT. And that also involves, often cases, training, change management, and of course, managed services. We have a number of offerings based here in LA, and I'll talk a little bit more about that. But before we get to that, we'll talk a little bit about why work with us and sort of what makes SADA special. So we're consistently ranked as one of the best places to work by the LA Business Journal. We're based here in Los Angeles, and we're very proud of that. We have a great corporate culture, and we try to exude that to our customers as well. We've won the Google Maps for Work Global Partner of the Year award, I want to say 3 years consecutively now, definitely the last 2. And we try to replicate that same level of excellence across all of our practices as well. We've also been the North America Partner of the Year for a few years for Google Apps, just to exemplify how we definitely strive to bring the best to our customers across all of our product lines. So why work with SADA? So first of all, like I mentioned earlier, we are a premier partner across all of Google for Work. And why that's important is we're able to offer holistic solutions that aren't just focused in one area or another. We can build workloads that involve Maps APIs, that involve Google Cloud Platform, that involve Google Apps, so on and so forth, to make sure that whatever we're providing to you makes the most sense for what your business needs, regardless of where it falls into the various product categories. Also, we're based in LA. We're founded in North Hollywood. We still have our headquarters up there, and we're close to you. We like to come on site. We like to get to know our customers as much as possible. And so we're also able to offer a 24/7 LA-based support desk. This is important because when you call us, you're going to get somebody who's sitting in North Hollywood. You're going to get somebody who's probably somebody you've spoken with before. And our team is going to know your business, is going to know the problems that you face often. And we'll know your deployment, know your goals, and we'll be able to help you better than calling into, say, a call center and speaking to a new person every time you have to submit some type of trouble request. We're able to help you right away. Because we're all in the same office, our help desk is able to work with our engineering team, work with our consultants, work with our trainers, and really provide more than just a tier 1 or tier 2 support experience. We can really help consult and navigate where you're trying to go with whatever problems you're facing. And then finally, one of the main reasons that customers like to work with SADA Systems is because we quarterback the entirety of the GCP deployment. And so you saw a number of great speakers today talk about a number of different options and routes you can go within GCP. We are able to sort of serve as that pivot point and navigate the community of Googlers, navigate the community of fantastic technology partners that you heard from today, and really prescribe the best solution based on everything that's out there for what you are trying to accomplish. And if we don't have an exact solution, we can help you look at all the solutions that are out there and work through it together and figure out what makes the best sense. We have a number of customers, like I said, we've been doing this for a few years now since everything was in beta, so we've seen a lot of things, how they can go right, how they can go wrong, and we like to sort of cut the learning curve as short as possible and help you get to where you want to be as quickly as possible. So, as you can see, I'll skip through this pretty quickly. I know we're short on time. We've worked with a few pretty big logos you may recognize, and there's definitely a lot more than what's on this slide here. This just gives you an idea of the quality and scale of the customers that we like to work with. And again, in the essence, or in the effort to save time, I will be around after this. If anyone has any questions, I'd love to chit-chat about specific use cases or how we can help you really accomplish anything in particular. And thank you so much. Next, we have Todd from Google. He's going to talk a little bit about security.
Everyone can hear me? Great. First of all, thanks for coming. I know this is a very early morning as far as LA Post goes. Some really good news. There'll be more coffee momentarily, or if it's not already here, it might already be here. So if you get up in the middle of my presentation and get coffee, I will totally understand it. So I'm Todd Previs. I am the product manager for rendering on Google Cloud Platform. So my responsibility really falls to all of the product roadmap things we're developing. So as Jeff spoke about earlier, we have Zinc, and there are some additional API things we'll be looking at developing in the second half of the year to help larger studios, such as yourselves, migrate more easily to Google Cloud Platform. But in terms of today's overview, I really want to talk specifically about security on Google Cloud Platform, both holistically what we've done, as well as things we've addressed specifically for the feature film and sensitive television commercial content industry. And as Jeff mentioned, when he was up here speaking, we got together at the beginning of the year, or when he joined, there was a list of what are the major things that are blockers, right? Obviously, licensing came up, and we have some solutions for that, and we'll very likely be offering more of a holistic offering in the future. But another really critical thing is security. A lot of you are working on very sensitive pre-release theatrical projects, and there's the issue around what studios will and will not let you put on Google Cloud Platform. So I'd like to spend a few minutes today talking about our cloud security and giving you an overview and an education as to what we're doing. So over the last several years, we've really seen a shift from the public perception of cloud not necessarily being as secure as your on-premise environment to a flip-flop where cloud is really the standard for security. When you look at the major public cloud providers, and Google being one of them, of course, it is our business to protect user data. We have billions of users, both on the enterprise and on the individual level, and maintaining the integrity of that data is really critical, core to our business. So as you can see here, these are typically a lot of the types of breaches that happen in on-premise environments, and we've seen some pretty high-profile breaches. You can see up there, Sony, Target, Home Depot, and Ashley Madison happen in which user data has been exposed to the public. So what we have at Google is really the end-to-end supply chain, right? We build our own servers. We write the hypervisor software. We lay the groundwork for the fiber. This is all integrated in a single offering that Google Cloud Platform now makes publicly available to you as the user. And keep in mind, from a holistic overview, Google Cloud Platform is the same infrastructure that powers Google. So when I talk about the need for Google as a corporation to protect user data, it's not just on the enterprise level where you might be using it for rendering or for transcoding or for storage, but it is the very fabric of what keeps Google running as a company. And in terms of the different steps we take to build this end-to-end solution, secure solution, it really starts with our people, right? We have over 500 security professionals, many of whom literally have written the book on security. And these people are employed by Google. We are the first company to start offering a reward vulnerability program to incentivize people to try to break us, right? To try to find loopholes and addressing those and fixing those. And if you think about Google, again, as a platform, we are among the most targeted platforms in the world, and that goes everywhere from nation-state sponsored attacks all the way down to the individual hacker sitting in their basement trying to get through. So critical to our operation as a business is the security aspect of it. So I've spoken a little bit about the people aspect of it from a literal physical data center security standpoint. There's actually a video that's up on YouTube showing the advanced access restrictions we have. It's fully biometric. Myself, as a Google employee, I cannot get into a data center. I mean, these things are very locked down, very restricted in terms of who actually has physical access to even operate within these data centers. And then, again, we build the stack, right? We're one of the top 5 server manufacturers. We build the hardware. We build the hypervisor. We've laid the network. Everything end-to-end is controlled by Google. So what are we doing on the broader scale for security? Well, these are all the typical security certifications that you would see, stuff like ISO 27001, SOC 2, SOC 3, FISMA, HIPAA, et cetera. And you can go to cloud.google.com/security to read up more about the things we're doing within the broader security spectrum. But I understand what's really important for all of you in this room is how are we addressing the studio-specific requirements of cloud in today's environment. And there are several things we've done, and I'll walk you through those on a step-by-step basis. I think it's important to note, and for those of you, most of you in the room I think are aware of this, to understand the MPAA's position on cloud. So while they have published a best practices guideline for cloud, there is currently no certification. There is no MPAA logo program. Undergoing an audit for cloud with the MPAA does not get you clearance with the studios. So we've spoken to the MPAA about this, but what we've decided to do is work directly and closely with the studios, directly to educate them about Google Cloud Platform, inform them of our security and compliance, and in some cases actually undergo an independent third-party audit at the request of these studios to certify Google Cloud Platform for Tier 1 pre-release theatrical content. So I think the important thing to note is that we've examined the issues here. We've examined where is the real value in having security audits. I think we've started at the top with the most difficult and strict studios as far as security goes, and have now taken that information, taken that certification, and are working with the other studios to essentially vet out Google Cloud Platform. And again, this is not going to be an open the floodgates to everyone. As this is a very new technology, we know studios are somewhat hesitant to embrace this. They're worried about leaks, talking about billion-dollar tentpole films and data getting out. It really is now on a case-by-case basis, but it's important to understand how closely we are working with these studios, how we're working to provide prescriptive hardening guides to show the implementation of your pipeline on Google Cloud Platform to enable pre-release theatrical rendering happening. And as part of the work we've been doing, there's some things we'll be publishing by the end of this quarter on our website. And all of this material is now available directly to you. You can contact Lauren, and she has access to all of this and can provide this to you ahead of time. But we will be showing or providing this independent audit that we've undergone, showing how we map to the MPAA standards. So again, while not necessarily giving us the ability to get a cloud certification through the MPAA, this is at least showing how we do map to those standards for any of you that are concerned about that. And we'll also be publishing a best practices hardening guide for how to safely and securely deploy your cloud rendering solution on Google Cloud Platform. So in the end, this is really all about giving you, the customers, control over your security, while at the same time understanding that within this industry specifically, there are definite requirements and needs and relationships that need to be maintained with the big six studios who are giving you much of your work when it comes to feature film content. And I'm confident to say that we've done a great job so far, and I'm really looking forward to a lot of the things we'll be able to talk about sort of as the year progresses in terms of projects done on GCP for major feature film releases. So next, I am going to turn it over to our panelists. I believe Jeff Kember from Google will be up, along with Jim Thompson from Avere. And I'd also like to introduce the folks from 8VFX who are going to speak. So we'll go ahead and get the chair set up and start our panel in just a moment.
Hey guys, and just while we're getting the chair set up, there's just one thing I wanted to point out. So Google does not have an official GPU offering at this time, but what we do have is an interest in hearing from you on, do you want them? If you do, come see me after and let me know if you want compute GPUs or display GPUs, how many you might want, how you might use them. We're just kind of taking some information, so we have a little survey that we can send you as well that you can fill out a little more concrete. But so again, as we all know, most of the compute loads are render on CPU, but there are remote desktop workloads and other magic things that happen well on a GPU. So please come and talk with me after the show. Or actually, can I just get a show of hands? Who's interested in GPUs? Okay, that's pretty good. I like that. In fact, I want to take a picture of that for the product manager because he asked me to ask. So hands up again, please. Awesome. Okay. And got it. Thank you very much. For you, sir.
Okay, so we now have our panel discussion. I'd like to bring Jeff Kemmer back on stage, Jim Thompson, and Damien and Philippe from 8VFX, who have actually gone ahead and deployed a rendering pipeline on GCP. Does everyone have microphones, or am I going to be passing the microphone? Okay. So Damien, do you want to start and just give a little bit of an overview about 8VFX, some of the work you've done, and your decision to move to Google Cloud Platform and how you've set that up?
Okay. So, as you know, when you are a company that does some visual effect for commercial, you have some time to render quickly some image. And because we have a local render farm, but we have to extend, we have to have more power to use to render this image. It is why we choose to render on the Google Cloud. And voilà.
Great start, absolutely. Philippe, do you have anything else to add to that?
Yes, so, excuse my English to begin with. So we're, I would say we're a very small VFX studio. We have about 20 artists. So I know there is a list with very big companies here on the right, and that it looks like Avere and Google Cloud is made for big companies, but it's not. We have very specific needs. When we need to do some rendering, we don't need thousands of cores, but we have a local, small, on-premise render farm. So we sometimes need to fire up some more power on the cloud. So, I mean, it's target for every kind of company, the big one and the small one, like us.
Great. So we have a few panel questions I'd like to start with, and then certainly take some questions from the audience as well. I think one of the things I would like to start with is talking about latency. It's a good question with the Avere folks and with the 8VFX folks. So how does cloud impact performance for you, and how does that affect your pipeline, and how have you managed to essentially push assets up for optimal rendering?
I know that normally we can't, the problem was that because we are using a lot of custom data inside the scene, like a lot of texture geometry, the first solution that we try is to use some script or plugin to scan all the scene and find what we have to send to the cloud before to render. And for me, it was not a good solution. It is why I talk about this with Philippe here, and ask him if it is possible to have something that can transfer all the data in real time between my company and the Google Cloud. And Philippe told me that there is a solution. This is Avere, and well, I think he can talk about this more than me.
So in my previous company, we had physical Avere cluster. It was composed of 6 nodes, and we had about 5 petabytes worth of data. So this was our local storage. And yeah, before having the Avere, we really had a lot of I/O issue, and working with Avere really helped us. So in this company, I wanted to give a try to the cloud solution, because when we began to do the testing of rendering on the cloud, we were directly connecting our render farm to our local on-premise storage, and it was awful. So it was. We began with Windows. We are a full Windows studio. So our clients are Windows machine. Our storage is a Windows machine. So yeah, basically it's full Windows. So when we began to do the rendering on the cloud, we had some huge latency issue that were not only due to the number of access done by the render, but also because when you use SMB, from a WAN, from a VPN connection, you will have very, very low transfer, because SMB is not a protocol that has been thought to be used over a WAN, because it's a very chatty protocol. So we had to use NFS between the cloud and the on-premise storage. So Avere was a good solution for that, because we would put virtual nodes on the cloud that would connect to our on-premise storage directly, and using NFS, so we wouldn't have any kind of those latency issue, and it would of course help us because we had a lot of virtual render on the cloud that would read the same files. So basically, when you're using the Avere caching system, you read one file once. If you have like 100 nodes on the cloud, and they access the same file, they will only read the file once. So yeah, it was a huge benefit.
Great. So along those lines, Jim, Avere as a filer, when would you choose, or why should I choose Avere over other filer options? What's the ideal workflow scenario for that?
Yeah, anything that's cacheable. Again, the Avere is a caching layer. So if there's something that and it won't work for everything. Absolutely, right. You really have to understand your flow and what you're doing as far as a render is concerned. If there's going to be repeatedly accessed content and assets that you need for the render, the Avere layer, caching layer, is going to be very important to cache all that stuff, because otherwise each individual render node is going to access the storage, your on-prem storage, over and over and over again. So it's going to consume all that throughput and all that bandwidth that you have from the cloud back onto on-prem. So having us in the picture there, in the data stream, is going to alleviate all that latency. I mean, not all of it, but I mean most of it, from accessing all that data that you're on-prem, and then eventually get your renders done in a timely manner instead of taking a much longer time.
Great, thanks. Jeff, next question for you. Having worked with studios all over the world now in terms of getting them set up with VFX rendering pipelines, what do you see as these studios finding the single biggest challenge to getting onto cloud being?
I would say the single biggest challenge is the social engineering with production. The idea that, well, the artists are just going to use all the disk space and all the compute, and pricing is going to be a problem, and how do we manage this? I touched on it a little bit earlier. The idea of producing a matrix, a spreadsheet of all of the various performance aspects, and also trying to come up with a cost for what render looks like. But it really comes down to, in my mind, talking with production and having them manage how many machines get spun up and such, or you can have your CG soups do it. But you know, the questions came up. I was in a meeting yesterday where it was like, well, do we want the render wranglers to do it, or do we want systems and pipeline to manage it? And well, no, it's always going to be a production problem. And that's kind of the human factors issue. the excellent work that's been done on security with Todd and Matto and others, that's like a solved problem at this point, and it's just sort of propagating throughout the industry. There's obviously additional work to be done, but that isn't the elephant in the room to talk about. And we have file system support and direct connect, and licensing is a problem that is going away. So really, it just, for my money, it comes down to adoption in the workplace and how to best engineer that.
Cool. Back to the 8 guys, Jeff mentioned costs and total cost of ownership. So obviously you have a small on-premise render farm now. At what point do you decide to put jobs on the cloud, and what sort of cost analysis or comparisons have you done to what it costs to run a render locally versus putting it on the cloud, and what additional, I guess, benefits beyond just the $1-to-1 dollars do you see using rendering on cloud?
So on my point of view, as an IT guy, I didn't really think about it as a cost point of view, but as the fact that when you need to do something fast, you have to have the power right now. So if you want to see it on a cost view, usually when we need to render stuff that we need to render fast and we don't have enough power on site, we just rent machines. Renting machine, usually you rent a machine for 1 week, 1 month. Using the cloud, we just fire up how many machines we want. If we want 5 render, we launch 5 render. If we want 100 render, we just launch them. And it's for the time we need them. So if the render will take 12 hours, we will pay for 12 hours, not for 1 week.
And then in terms of costing out what it costs on cloud, are you able to yet bill these jobs back to the clients, or do you figure it into the actual cost of production, or how does that side of it fit into your production schedules?
Before to start a project, we try to know what will be the cost of the rendering side, and we try to add a maximum of 3 render on the cloud. It is why before we have a budget and we know, so this is completely integrated inside the production.
Great, cool. Jim, back to you on the Avere side. So we're starting to see more and more small studios that don't necessarily have an Avere on-premise caching appliance deploying Avere on the cloud. Moonbot Studios in Louisiana is a great example of that. What information can you give us about that, and share sort of the advantages to studios that might not necessarily be investing in an on-prem appliance, but still getting the benefits of being able to set up a scalable cloud filer with cache?
Yeah, it's similar to what Philip just mentioned here, is that anytime you need some type of burst computing, and this is what Moonbot needed. They needed to get rendering done in a timely manner. In order to do that, it was just physically impossible to get stuff on-prem to do that. They could afford it, but the thing is that they just didn't have enough space, and there's other power issues and other things. And this is for it could be anybody, absolutely, and across any type of environment. So what they did is they had to think about different ways of doing this. And the only way to do that was to actually put something up in the cloud and utilize the cores to get the jobs done. And the thing is like Philip mentioned as well, is that you could spin up 100 cores, you could spin up 2,000, you could spin up 30,000. It depends on how quickly you want the job done. And that's what they did. They actually spun up I can't remember exactly, but I think it was over 5,000 cores at a time. To render to get their jobs done. It's really that simple. If you need something done in a critical timeline, you have to go out, think outside of the box to actually find a solution, and this is the only way to do it.
Great. So back to you guys on the whole job management side of things. Since there is this concern about costs on the cloud, how do you manage submissions? Is it done through a typical artist workflow, or is it centralized to a render wrangler or a different way in your pipeline?
Yeah, so currently on the artist side, this is just one checkbox. You have to choose if you want to render on the local render farm or the cloud render farm. So we are using Deadline, and the process is exactly the same between the cloud and the local render farm. So on the pipeline side, I didn't have to do a lot of change. So currently, when a user choose to use cloud rendering, he will send a job into Nearline, and Nearline will generate some. We are using Avere, so the render farm will generate from Maya all the VR scene, and we are using the local render farm. And after, another job will take all the VR scene and render all of them inside to the cloud from the cloud rendering.
Okay. And Jeff, what are your observations working with the really large studios that are using 30, 40, 50,000 cores on GCP? How do they manage artist submission of jobs to cloud?
Good question. Yeah, we have some companies that are running more than 60,000 cores on a job. You run into a scenario where you have a ride film come in and it's 6 or 12K or 24K because it's a dome projection and you just don't have the multi-100 gig machines in quantity with 64 cores sitting around. So they're expensive, but you can get them from us. So in terms of submitting jobs, some of the companies I'm working with have their own queuing system. There's two different ways to do it. One of them is to have the queuing system dynamically manage the spin up of new machines. Another way to do it is to actually use a script to spin up machines and then add them to the queuing system. It offers a little more manual control doing it that way, and it just has to do with whether you're using a commercial or off-the-shelf, a commercial or roll your own queuing system. So those are kind of I think the distinctions in that regard. It also comes back to the production issue of, who gets to control that valve. Most of the time, it ends up being someone in a CG suite position who talks with production and controls how many machines are brought online. A couple customers I work with, though, are using a really dynamic model where they're averaging the usage. So they've budgeted to render like tens of thousands of cores on a sustained level, but they're able to say, hey, I only want to run, like if I'm good for 10,000 cores for 24 hours, they'll run 20,000 cores for 12 and utilize the wall clock savings. So that's kind of more advanced, but that's really beneficial for the artists as well.
Cool. So I just have one more question before we open up to the audience. So having set up a cloud rendering pipeline, what recommendations can you give to those in the audience who are looking to set something up based on your experience so far?
I think for the pipeline, before we have to have a good IT, and no, because for me the workflow to render all the job is exactly the same between the cloud rendering. This is completely transparent for me. So I didn't have to do a lot of change inside the pipeline because the cloud rendering know what we are using, what file we have to render. This is more an IT work than a pipeline work. So it is why this is very easy and to integrate this in the pipeline.
Great, thanks. So some questions from the audience. Someone out there has got to be.
We have plans.
Yeah, go ahead with the mic.
Thank you. My name is Reza from NextVR. Do you guys have any solution for live broadcasts in terms of pipeline, ingest points, as well as the caching, let's say?
So in terms of a real-time transcode,
Yes.
and such, yeah. There are some solutions for that. We can talk in more detail afterward. But yeah, there's a number of partners we have that are able to do a real-time transcode with a variety of output files with different codecs and different resolutions and such. So that definitely happens. The majority of customers I work with are doing an offline transcode, and that's super easy to do. The real time, as you know, latency does play, and the question of how many seconds do you want between ingest and push out to the CDN. The other questions include, are you pushing to your prem and then you're doing a distribution from there locally, or are you using Fastly, or we have a variety of partners. We also have our own CDN as well. So happy to talk with you more about that.
Thank you.
Thanks.
Any other questions? John.
Just we have people remote as well. We're recording, so.
Oh, sorry. What ISPs are you guys here with in LA, and what bandwidth are you working with? And was that ever a question or an issue?
Yeah, no, we have really fat pipes here into LA. One Wilshire for sure, and I can check the network diagram to see we have multiple peering locations. But
from a studio standpoint.
Well, from a studio standpoint, in terms of how large a pipe can you get into us, or?
Yeah, is that a concern at all when you're dealing with the cloud rendering and stuff?
Yeah, go.
So we at 8VFX, we have a basic 100 megabit link with that can have sometimes very bad latency. So I've noticed that when we have under 70 millisecond latency, you will have great transfer even using SMB. And if you have over, let's say, 100 millisecond latency, you have to use NFS. And we can, when we do some basic transfer between on-premise and the cloud, we can max out the link. And so when we transfer data with the cache, the Avere, we just use all the available bandwidth. We don't have, and now with the Avere, we don't have any real bandwidth issue. We did before because all the renders would use that single 100 megabit link. In the future, we would like to use a better link, not more speed, because 100 megabit is enough, but maybe with a lower latency. Yeah.
Thank you.
We just, a further data point, one customer in Central Asia was doing the 60,000+ core render. They had a 250 megabit symmetric pipe with Avere, and they were rendering in Iowa, so like 140, 150 milliseconds away. We also have customers with dual bonded 10 gig pipes into us as well, so it runs the whole gamut.
Hi there, Mark Lemons with Deluxe. My question is, as you've done this, how much of your go-forward render node provisioning is, if you were planning on future projects, would be cloud versus on-prem?
I think it depends a lot about the size of the project, because we have a local render farm with like 40 nodes, and for little project this is okay, but when we know that this is a big project and when we are doing a bid, we know that we have to do a lot of rendering. It is here that we decide, okay, for this shot or for this sequence we will use the cloud rendering.
Yeah, so until now, until a few months ago, we were using 100% local rendering, but now we know that for the future, we won't buy as many render nodes as we were planning to, because we have this online resource available all time. So when we will be moving our office in a few months, and the rendering, the sizing of the power of all the racks for the render is not as a big issue as it was before we used the cloud.
Yeah, it gives us a good security, because before we was a little bit scared to get some big project, because we didn't have any cloud rendering, so we didn't know if you can render all the project or not. But no, because we know that we have unlimited power, we didn't have any difficulty to render.
Great. Question, yep.
Mike Shida with Deluxe Creative Services. You have multiple locations at 8VFX, I saw. And do you share projects across those locations that have used the cloud, and are there issues that you didn't anticipate?
Currently, I don't know if the cloud rendering is working in New York.
So for now, we have a location in Los Angeles, in New York, and in London. Currently, the only location that is using cloud rendering is Los Angeles. We share project between New York and Los Angeles. The pipes Damien wrote is able to synchronize all the assets between the facilities. It's funny that you asked this question, because this morning our CEO asked us, can we do cloud rendering in New York? I said yes, because it's exactly the same. Basically, in Los Angeles, on an artist point of view, you just click one button to say, okay, I want to render on the cloud. Clicking this button will add your job in a specific group. So after that deadline, we say, okay, this is the Google Render Cloud. I will first begin to render locally. If I don't have enough power locally, then I will fire a certain amount of cloud rendering. So this is exactly the same, since our pipe is the same in Los Angeles and New York. They can do the same. They didn't do it yet, but they can do it. The only thing they have to do before, of course, obviously, is to set up a VPN between their facility to our cloud network. And yeah, it should be the same. It should work the same.
Currently, we are using Aspera to synchronize all the assets and all the pipeline between New York and Los Angeles.
Any other questions? Chris?
I have a question. Obviously, you've started to replace our part of your render farm with cloud, and it's been a good solution for you, and obviously a replacement for the rental model that you've probably had before. But do you see yourself moving completely to cloud, and not only that, but actually replacing the workstations with cloud machines down the line, where you can actually just VPN or just get into the machine remotely?
So for the rendering point of view, we still want to have some local render power. We don't want to put everything on the cloud, because all VFX Studio will do rendering, at least some hours of rendering every day. So on a cost point of view, it's more interesting to have at least a certain amount of local rendering power, and to have the availability on the cloud, to have more power availability. So this is for the rendering aspect. After that, so you asked for the workstation, right? We are currently testing some solution with Teradici. Maybe you know this technology that will it's a PC over IP solution that is quite cheap compared to the usual KVM solution, and that will allow you to connect to not only physical distant machine, but also virtual machines. So until now, we've done some testing with not artist workstation because of the GPU stuff, but on classic workstation, producer workstation, connected either to physical workstation or virtual workstation using VMware. It works. And now, with the new version of VMware that is handling that stuff, they will handle the GPUs. So we are really thinking about in the future, medium future, to virtualize some of the artist workstation using PC over IP solutions. So I didn't think yet about if we will do it on our local data center or on the Google Cloud. But yeah, I will test this very soon, I guess.
On that, do you have a figure in your head on what's the maximum latency that will be acceptable for artist workstations?
Yeah, so it's about the same latency I talked about before. 70 milliseconds is when your artist will begin to bitch about the latency. They won't notice before. Actually, last week, I've put an artist on a PC over IP setup without telling him anything. So there was a workstation right near him that was shut off. It was not running. And yeah, it was working, and he didn't know it was not working locally, but on a virtual machine. Yeah, so.
We have run some tests. But I have customers who have run some tests, and they echo that as well. It's typically the Mari artists who are most temperamental. They, every brush stroke gets written, so they want SSDs locally. But lighters and everyone else can certainly be pushed off. The testing other customers have done suggests kind of a 20 to 40 millisecond, but we've also had numbers as high as 80 with artists who are doing, modeling when you're pulling verts, that and painting. Those are the two critical ones. But we've had compers running at 100 milliseconds without a problem. So I think there's some variance within the job functions.
Any other questions? Okay, well, I'd like to, oh.
Right, so I know all you guys are into the X Games, so this is going to go great when you're doing your activities. It's a GoPro, right? Put on the end of your surfboard, dirt bike, whatever.
We wrote down numbers and it corresponds to everybody that's here. Lauren's got the names in the back.
Right, so I'm going to yell out a number and it means nothing to me. 3. Anthony, right on. Got a GoPro.
Congratulations, Anthony. I'd like to thank our panelists, our presenters, SATA Systems, who's here in the back, Simon and his team, if you have any questions regarding system integration. Thank you to all of you for coming, and thank you to Lauren for putting this all together. So we'll all be here if you have questions afterwards.